Okay, then the second property of the light that what I am going to discuss is that the light is going to travel with some speed. You know, my dear students, each and everything, especially in the space, is exactly measured with the help of the light year and also with the help of the speed of light. Dear students, the speed of the light is written by the letter capital C. So that the speed of the light in air, the speed of light in air or a vacuum is considered as 3 into 10 to the power of 8 meter per second. So even we can consider C as the speed of light, and also it is also considered as the velocity of light, especially in case of when it is traveling in air or vacuum. Dear students, whereas the velocity of this light, that is about 3 into 10 power 8 meter per second, changes when it travels from one different medium to another different medium. Not only this, even light exhibits photoelectric effect. Light exhibits photoelectric effect. So as well as light shows some phenomena like reflection, refraction, and even we can consider interference, diffraction, and polarization. My dear students, here you can observe that the last 2 points that what I written here I just written exhibits the photoelectric effect, and also the next one I written that it is going to show the reflection phenomena, refraction, interference, diffraction and polarization. So then the last 2 points are the main thing, especially that what you people are going to study in your second POC. To study that, to study this, the nature of the light energy, to study the properties, to study how actually the light ray is going to propagate, we are just moving towards a branch of physics called as optics. So whereas optics, it is a branch of physics, my dear students. Optics is a branch of physics which deals with the study of, actually the optics itself says that it is going to deal with the ray like nature, it is going to deal with the particle nature, it is even going to deal with the wave like nature of light. So that in general I can say that it is going to deal with the study of phenomenon of light, or it deals with the study of light energy. Simply I can say in that way also. Then it is going to discuss the phenomena of light. Then how many phenomena of light are there? See, there are so many phenomena: reflection, refraction, interference, diffraction, polarization and photoelectric effects. Now, for this reason, to divide these phenomena, I am just going to study other 2 types which was present in the optics. First one is ray optics. Second one is physical optics. There are 2 types of optics. There are 2 branches in optics. One is ray optics and the second one is physical optics. Dear students, ray optics is a branch of optics. It is going to deal with the study of ray-like nature of light. Ray-like nature of light. But dear students, the physical optics has again divided into 2 categories. One is wave optics and the next one is quantum optics. See, ray optics exactly deals with the ray-like nature of light. Similarly, the wave optics deals with the study of wave-like nature of light. wave nature of light. But the last one, quantum optics, deals with the particle nature of light. Deals with the study of particle nature of light. You can see that ray light nature, wave light nature, particle nature. It means light is having these many dual nature. It means it acts as a ray, it acts as a wave, and it acts as a particle. Then here we have so many phenomena. In this phenomenon, reflection and refraction comes under ray light nature of light. Interference, diffraction and polarization comes under wave optics. And the last, photoelectric effect comes under particle nature of light. Repeating again, reflection and diffraction comes under ray light nature. Diffraction, interference, polarization comes under wave optics, that is wave light nature. And the photoelectric effect comes under particle nature of light. But my dear students, now we are just moving towards, in this class, we are just moving towards the discussion of ray light nature of light. That is what we are under ray optics chapter. Whereas in this ray optics chapter, especially we should discuss the reflection and refraction. But this year they removed some of the concepts which comes under the reflection, so that we are just moving towards the discussion of the refraction phenomena. Before going with the refraction phenomena, let us see what is monochromatic light. What is monochromatic light and what is composite light? So white light is called as composite light. Hope you know that white light is termed as composite light. Why? Because white light is with 7 colors. That's why white light is called as composite light. It means the light with so many wavelengths, the light with so many frequencies. When we come towards a monochromatic light, mono indicates that the single, chromatic indicates that color. So that the single colored light is called as monochromatic light. Or even you can say that the single wavelength light is also called as monochromatic light. So this is about monochromatic light and composite light. My dear students, with this, if I want to discuss the refraction phenomena, first I should know what is ray of light and what is beam of light. First let us come to see what is ray of light. Dear students, if I just write that a straight line, right, with an arrow mark. So this indicates the ray of light. See, in this chapter, even if you write the ray diagrams and the telescope diagrams very perfectly, and if you forget to represent the arrow mark, you will lose complete marks. So that keep in your mind, representation of direction of light ray is much required, much essential. Dear students, a straight line with an arrow mark. Straight line with an arrow mark. See, I am just writing here. Straight line with an arrow mark represents the ray of light. What is this arrow represents? This arrow represents in which direction exactly the ray of light is propagating, right? So that the arrow mark indicates the direction of light. This is said to be the ray. Then what is said to be the beam? Almost all you are observing the beam of light. If you just switch on a torch, if you just switch on a battery, if you just switch on what I can say that a bulb, so that you can observe the light is going to split in all the directions. So here you can observe not only a single ray, you can observe n number of rays. So that the combination of n number of rays gives you beam of light. See, n number of rays combined together to give beam of light. Yes. Then, how to represent the beam of light? In this beam of light, we can observe three different cases. So just I am writing on the board, observe carefully. Now, I am writing the parallel beam of light. There are two or more number of rays are present here. So this is said to be the parallel beam of light. And now let us see the convergent beam of light. So these three rays, don't forget to represent the arrow mark. The three rays are going to converge at a point O. They are going to meet at a point O. So that it is said to be the convergent beam of light. Convergent beam of light. Similarly, dear students, there is another one type of beam of light that we should understand, that is a divergent beam of light. It means the rays of light are exactly coming out of a point. You can observe the diagram. Don't forget to represent the arrow mark. I am repeating again and again, so that the divergent beam of light. So these three are the beam of light which consists of two or more number of rays. So my dear students, this is about the simple introduction before getting into the ray optics. So especially when we come towards the phenomenon which will come under this ray optics, that is one is famous phenomenon, that is what reflection. With that we have another one phenomenon, that is what refraction. So we have very much experienced that if we just dip a stick inside a water, so that the stick appears to be bent. But actually it is not like that. It is due to the changing path, or it is due to the change in speed of light. So now let us move towards one of the phenomena called as refraction of light. Not only this, my dear students, when we come towards this refraction, so that there are two different mediums, so that medium 1 and medium 2, or even we can consider there are other two mediums like air and water, glass and water, glass and air, even you can consider diamond and water, diamond and glass. See, if we come towards different pair of media, we can observe different kind of refraction. So that first let us see what is the definition of refraction. It is the phenomenon of bending of light ray when it travels from one medium to another medium. Yes. Okay. See, I just tell you when a ray of light travels from one medium to another different medium, light ray is going to bend. Hope students you are just taking down the points and the definition that what I am writing on the board. So dear students, these are all the important definitions. So just take it and write it in your point notebook, and I am just going to check it when you come towards the class. And my dear students, you can see that just I defined it, the refraction. So I can give you a lot of examples, right? So that observing a bird which is flying in the sky. Not only that, observing a fish which is exactly deep inside the sea. Here we can see the different positions. Why? This is due to the refraction. Yes. Suppose if a fish observes a bird, fish is in a water, bird is in air. So we can observe the different position of the bird. That is what bird appears very far away as its original position. was flying in the air. For that bird, fish appears to be very nearer than its original position. What exactly this indicates? There is a phenomenon of refraction. So that refraction we can observe with the help of two different mediums. So I am just going to write the two different mediums here. Let us consider it as medium 1 and let us consider it as medium 2. Whereas this line exactly shows that there is a partition, this is what I have written, between the two different medium. Dear students, I am just going to draw the perpendicular line to these two pair of medium. So that perpendicular is termed as normal. Yes, I just written medium 1 and medium 2. Then which one is a rarer and which one is a denser? Dear students, if you don't know which one is a rarer and which one is a denser medium, we cannot observe the refraction phenomena exactly. See, now I am going to incident a ray of light from medium 1 on medium 2 at the point of normal. Good, that's enough. Then, which medium is rarer? I just want to consider. For that, let us take an example, A and glass. Medium 1 is considered as A and medium 2 is considered as glass. You know that from your 10th class, A medium is called as rarer medium as well as glass medium is called as denser medium. So this rarer and denser medium can be understood with the help of refractive index. That let us study in the next class. But now let us see. One ray of light is going to travel from rarer to denser medium. It undergoes refraction. Dear students, here a ray that is said to be PQ is said to be the incident ray. PQ is said to be the incident ray. Whereas the angle which was present between the normal and the incident ray is called as angle of incidence represented by I. So I am noting here PQ is called as incident ray. See now this is just a starting class for the ray optics, so that I am representing all the rays and all. In the next class I am not going to represent all such things. So whereas I is called the angle of incidence, right? Now, if I just draw this, if I just extend this, it moves like this. It means it is a direction of incident ray. This is the direction of incident ray. Just extended the incident ray. It means if there is no second medium, if the second medium is absent, what happens? The ray passes out in the same direction. But now, the second medium is present here. Due to the presence of the second medium, what actually the thing is going to happen? So due to the presence of second medium, we know that light when it travels from one medium to another medium, its speed changes, its velocity changes. It means the speed and the direction changes. So my dear students, the ray of light is traveling from one medium to another medium. So the speed should changes. So it is going to bend. It is going to bend. Right. So that QR is the refracted ray. QR is the refracted ray. QR is the refracted ray. Now, the angle which was present between the refracted ray QR and the normal. The angle which was present between the refracted ray QR and the normal is called angle of refraction, represented by symbol small r. So small r is called the angle of refraction. Right. Angle of refraction. Dear students, see here, whereas this direction, this dotted line indicates that the direction of the incident ray. It means suppose the second medium was absent, so the light ray may travel in this direction. But due to the presence of the second medium, the ray of light bent. Then there is an angle. You can observe that the light ray should travel in this direction if the medium 2 was absent. But now it shifted to this position. It means it deviated. It has been deviated. It has bent. So that angle is called angle of deviation, represented by small d. Angle of deviation. Angle of deviation, represented by small d. Please be clear now. PQ is the incident ray, QR is the refracted ray, I is the angle of incidence, R is the angle of refraction, and D is the angle of deviation. So then let us define angle of incidence. What is angle of incidence? The angle present between normal and incident ray is called angle of incidence. What is this angle of refraction? The angle between refracted ray and the normal is called angle of refraction. And then what is angle of deviation? Angle of deviation is an angle present between refracted ray and the direction of incident ray. Refracted ray and the direction of incident ray. That is called as angle of deviation, represented by D. So only this much we discussed. That is what when a ray of light travels from medium 1 to medium 2, what happens, like that we discussed here. If I just consider that when a ray of light travels from rarer medium to denser medium, how the ray of light is going to bend, and when a ray of light travels from denser medium to rarer medium, how the ray of light is going to bend. Here I just already showed you that. I just considered this one as rarer medium and the next medium as denser medium. When ray of light travels from rarer to denser medium, it always bends towards the normal. This normal, this is said to be the normal, whereas QR is said to be the refracted ray. It starts bend towards the normal, so that when ray of light travels from rarer to denser medium, ray of light, refracted ray, bend towards the normal. I am just writing here, refracted ray bends towards the normal. Yes, this is one point. The next one is, you can observe very carefully that the angle of incidence is greater than angle of refraction. So easily you can note it in the screen, right? See like that. So this is said to be the angle of incidence. According to the mathematics, this is said to be the angle of incidence. The angle of refraction is small compared to that of angle of incidence. So that I can say that angle of incidence is greater than angle of refraction. Then with the help of mathematics, how to write the angle of deviation? D can be written as I minus R. D can be written as I minus R. And please be careful, when a ray of light travels from rarer to denser medium, speed of the light, decreases. Speed of the light decreases. So these are all the points when ray of light comes from rarer to denser. Now let us see another case when the ray of light travels from denser medium to rarer medium. So I just consider two different mediums, whereas I am going to draw the normal here, right? Whereas N is said to be the normal. Now I am going to incident a ray of light. Let us consider that. See, I am just representing the ray or direction of ray of light. PQ is said to be the incident ray. The angle present between the normal, and the incident ray is called as angle of incidence, and this is the direction of incident ray. It means if in case the second medium was absent, the ray of light should travel in that direction. But now the ray of light is traveling from denser to rarer medium, so that the ray of light always shifts away from the normal. See, here it is exactly towards the normal, but here it is exactly away from the normal. QR is said to be the refracted ray. See, the angle which was present between the refracted ray and the normal is called as angle of refraction. Actually, the ray of light should travel in this direction. In this direction, suppose the second medium was absent, but due to the presence of this medium, it has shifted away from the normal. So that it has deviated from this direction, this position to QR position. So that the angle which was present between the direction of incident ray and the refracted ray is called as angle of deviation, represented by small d. Dear students, now let us point out some points which when the light ray travels from denser to rarer. Hope you are all taking out the points. So that, my dear students, here when a ray of light is traveling from denser to rarer, it bends away from the normal. Hope you are all just repeating the words that what I am saying, bends away from the normal. Away from the normal. Yes. Now, as well as observe the diagram very carefully. If this is an angle of incidence, so that according to the mathematics, so this is considered as angle of incidence, right? So then you can observe here very carefully that angle of incidence is smaller compared to that of angle of refraction here. So that when a ray of light travels from denser to rarer medium, angle of incidence is lesser than angle of refraction. As well as I can easily write the angle of deviation, so that by just considering the mathematics, so here is d, so that d can be written as r minus I, d is equal to r minus I, and finally the ray of light is from denser to rarer. What happens now? The rate of light, the speed of the light is going to increase. Speed of light is increases when it travels from denser to rarer medium. This is what the basic definition and how the ray of light is going to bend when it travels from one medium to another medium. With this, now let us move towards the discussion of laws of refraction. Dear students, in your 10th class, you might have discussed the laws of reflection, in which the first law states that the incident ray, the reflected ray and the normal drawn at the point of incidence all lie in the same plane. Similarly, when we come towards the laws of refraction, here also we have two laws. But in that the second law exactly shows you that the angle of incidence is equal to angle of reflection. But here we have two laws. The first law is exactly defined as similar to that of the law of refraction. But the second law is one of the special law called as Snell's law. Let us see here laws of refraction. What exactly the first law states. For that I am just writing the previous diagram. So I am not going to explain it again and again. So I am just considering the two different medium. Let us call it as 1 and 2. So the ray of light is going to incident. So that with an angle of incidence I, after refraction it bends towards normal with an angle of refraction R. So just I written all these things. So as I written while explaining that refraction. So I need this diagram to explain here. You can observe this incident ray PQ, refracted ray QR and the normal. All these things are lying in same plane. Plane means it is having only two axes, whether it may be xy, yz or zx. So this exactly these two rays, that is what incident ray, refracted ray and the normal are all in the same plane. So I am just writing it, incident ray, comma the refracted ray, see I am using the refracted ray, and the normal drawn at the pair of two medium all lie in same plane, yes, this is what the first law, right? So even you can observe that y plane and x axis. You can observe if you come towards this direction, x and y axis you have, here also x and y. It means it is lying only a same single plane. So it means it is having only the two axes. let us come to a special law called as Snell's law. So whereas in case of law of reflection, so you might have studied that the angle of incidence is equal to angle of reflection. But when we come towards the Snell's law, here it exactly shows that the sign of the ratio of sine of angle of incidence I to the sine of angle of refraction smaller is always a constant. Don't forget to write the next sentence, that is what, for a pair of given media and for a given wavelength of light. If you forget that statement, if you forget that last line, you will lose your marks. Why? Because this ratio is constant for particular set of pair of media and for given wavelength of light. Dear students, whereas this constant is called as refractive index. I already said that the refractive index is helpful to define which one is rarer medium and which one is denser medium. Now let us see that. So that constant is called as refractive index. Dear students, refractive index is represented by the symbol N, whereas in some reference books and also in some books, so it is also represented by mu. Keep in your mind, the refractive index is represented by N, or even it is represented by mu. Okay, N is said to be the refractive index. Then what is this refractive index, ma'am? Is there any different types of refractive index? Obviously, dear students, that what you studied in your 10th class regarding this refractive index, the same thing we are just going to discuss but in detail. So that here, when we come towards that refractive index, if I just consider there are two different medium, right? So for this two different medium, assume that the ray of light is traveling from 1 to 2. Then I want to measure the refractive index of second medium with respect to first. See, refractive index of second medium with respect to 1. It is how to pronounce it. So N21 gives you the refractive index of the second medium with respect to 1. It means the ray of light is traveling from one medium to second medium. Yes, this is the case. The ray of light is traveling from first medium to second medium. So this medium is having a refractive index N1 and this medium is having a refractive index N2. So that I should know the refractive index exactly with respect to one another medium. If I want to measure the refractive index of 2 with respect to 1, it is written as N21. If I want to write in reverse case, so that I want to measure the refractive index of 1 with respect to 2, it is written as N12. Right? Hope you are getting. So just I am showing you the representation how to write the refractive index. That is what the measuring of the refractive index of one medium with respect to another medium. So now here I am going to replace this constant by the refractive index, that is what, N21. By assuming that the ray of light is traveling from first medium to second medium. Not only that, my dear students, exactly when we come towards the discussion of the refractive index, again there comes two types of refractive index. One is said to be absolute refractive index, I am just representing it as Ri, and the next one is relative refractive index. Okay. Please keep in your mind that the absolute refractive index is always represented by N. It's simply represented as N. Even, my dear students, the absolute refractive index N is defined as the ratio of speed of light in air to speed of light in medium. Right. So that you know that the speed of light in air is represented by c and the speed of light in medium is represented by V, because from your first PUC the velocity or the speed is represented by the letter V. Dear students, when we come towards the relative refractive index, relative word, it deals with that we are comparing the velocity of a light ray which is traveling in one medium with the velocity of a light ray which is traveling in the second medium. So that the relative refractive index is always comparing or measuring the velocity of a light ray in one medium with respect to another. So that the refractive index of second medium with respect to one can be written as, please be careful, speed of light in medium 1 to the speed of light in medium 2. Please be careful. N2 with respect to 1 is written as the ratio of speed of light in medium 1 to speed of light in medium 2. It means speed is represented by V. For medium 1, velocity is V1, and for medium 2, the speed is represented as V2. See, N21 is written as V1 by V2. Absolute refractive index N is written as C by V. Then, how I just avoid this? N21 is equal to V1 by V2. Let us check it out, my dear students. So that N21 is equal to, see, N21 even can be written as ratio of the refractive index, that is what, N2 divided by N1. So as I defined you previously that there is an absolute refractive index, whereas absolute refractive index is a refractive index defined as a ratio of speed of light in air to the speed of light in medium. Assume that I want to write the formula for the first medium, especially the refractive index of the first medium, that is said to be N1. So how to write it for N1? Then N1 can be written as, by using absolute refractive index, C by V1. Similarly, how to write N2 with the help of absolute refractive index, I am writing it as C by V2. Now let us replace here. So what is N2 now? Here it is N2, that is what, C by V2. I am writing it as C by V2 divided by, what is N1? Here it is given that C by V1, right? So I am just writing it as C by V1. So C cancel with each other. So this denominator for denominator is always a numerator. So that V1 divided by V2. Hope you got. N21 can be written as N2 by N1, and even it can be written as V1 by V2. See, even we can write some other formulas also, my students. So hope for you people still you have not studied the electromagnetic waves chapter. But if you complete the electromagnetic waves chapter, you will come to know the relationship between the velocity and the wavelength. So whereas there is a relationship between the frequency, wavelength and the velocity, so that the velocity V can be written as nu into lambda. If suppose if I want to V1, I can write it as nu1 lambda 1. Please be careful, nu is a frequency and lambda is a wavelength. Similarly, V2 is written as nu2 lambda 2. Right? I am substituting that, but be careful that you are not just moving towards nu, right? So I am just writing it over here. So V1 can be written as nu lambda 1, V2 can be written as nu lambda 2. So that nu and nu cancel with each other, remaining is lambda 1 by lambda 2. So there are so many relations for N21. N21 can be written as N2 by N1, even it can be written as V1 by V2, and even it can be written as lambda 1 by lambda 2. Yes, if I want to write the formula for N12, how to relate it? Dear students, that is what N12, so just I am writing it over here, just observe carefully. Yes, N12 can be written as, see here, I am just showing you similar case. So while reading for the examination, just remember only one case. Don't go with another case. So that if you know the one case, it is opposite to the top, the second case. So whereas in place of V1, just replace by V2, and in place of 2, just replace it by 1. Similarly, you can written as lambda 2 by lambda 1. This is what the relation required for N1, 2. Not only that, in case of your 10th class, you know that the light ray exhibits the same phenomena when it is going to travel from the opposite medium. It means there is a principle of reversibility, so that the light traces the same path when it comes from this denser to rarer or from rarer to denser. But one thing is the direction is going to change, as well as the terms that what we are going to consider is going to differ. So that here for when a ray of light travels from 1 to 2, I written that it is written as N to 1. Suppose if the ray of light is traveling from 2 to 1, it is written as N1, 2. Both are inversely proportional to each other because of the principle of reversibility. So that N21 can be written as 1 by N12. Right? Already shown you that N21 can be written as sin I by sin R. Then here how to write N12? N12 is a reverse case. So that N12 can be written as sin R by sin R, right? Easily we can prove this. How to prove this one? You know that sin I by sin R already, so that it is represented as N2 with respect to 1. Assume that we don't know how to write this, but we know this reversibility formula. So let us replace here by sin I by sin R with the help of Snell's law, which can be written as 1 by N12. Then just take the reciprocal. So N12 can be written as sin R by sin R. Yes. Finally we got the expression for N12 as also for N21 with the help of Snell's law and also with the help of principle of reversibility. So this is about the absolute refractive index, and this is about relative refractive index and the Snell's law, and how to write the different formulas for N21 and N12. And in case of principle of reversibility, I just want to show you again here. Suppose if I just multiply N21 and N12, it always leads you 1. This is also a formula for principle of reversibility. How to give this? How to prove this one? N21 can be written as N2 by N1 into, it can be written as N1 by N2, which is equal to 1. So you can observe that. So these things cancel with each other, remaining is 1. Or else even you can prove in a different way. So just in place of N21 with the help of velocity I am writing, it can be written as V1 by V2 as I shown you before, into N12 can be written as V2 by V1. So that here all the terms cancel with each other, remaining is 1. So that we have proved it in a cross way also. It means always when a ray of light travels from 1 to 2 and 2 to 1, it retraces the path. This is about the refractive index. Then let us see some values of refractive index. Dear students, in our experiments, especially in case of discussing the refraction, we used to take a glass, we used to take a water, we used to take a air, right? So my dear students, the refractive index value for water, that is what NW is equal to 1.33. You should remember this value, and for your examination purpose, especially while solving the numericals, you should remember this one. And the refractive index of a glass is equal to 1.5, and refractive index of air, Na, or simply I can write it as N, which is always equal to 1. So you can observe, now I am going to compare two different mediums. If I just compare air and glass, air is having a refractive index 1 glass is having a refractive index 1.5. So that air is considered as a rarer medium and glass is considered as a denser medium, right? Now I am just considering again, see I am just going to rub this and I am just again going to consider other two medium, that is water and air. So air is having a less refractive index compared to that of water, so that air is considered as a rarer medium and this water is considered as denser medium. Similarly, if I just consider water and glass, we can observe that glass is the one which is having more amount of refractive index value, so that water is said to be the denser medium and glass is said to be the water is said to be the rarer medium and glass is said to be the denser medium. Dear students, if I want to write these things, you can observe that refractive index of glass is greater than the refractive index of water, whereas which is again greater than the refractive index of air. Keep in your mind these values so that it is helpful for solving the numericals. Dear students, hope I covered some of the main concepts which was required to study the lateral shift and also the normal shift. So my dear students, today's class ends up with this refractive index, my dear students. So that please try to note down the points always when I am just going to teach in the class. And one thing is, I am just going to post you the PDF in the Google Classroom. Copy the notes that whatever I am just going to provide there, and don't write advancedly. Just write the topics that what I have covered today itself. That's it. Okay, don't write more than that. Thank you, students.